So today's lesson is talking about parallel and perpendicular lines. And using parallel and perpendicular, we're going to be combining algebra with our geometry. So first of all, we need to define what a parallel line is. And parallel lines in geometry are lines or plane that never ever intersect or touch at any point. If they're lines, they have to be in the same plane. For example, if you think about your wall where it touches the ceiling forms a line because we know that intersecting planes form a line. The wall, same exact wall where it intersects the floor, also forms a line. Those two lines are parallel to one another. They are in the same plane of the wall. The same for parallel planes, two planes that never ever intersect, while your floor and your ceiling are parallel planes. Two opposite walls are parallel planes. When we're drawing them in geometry, we mark them with little triangles. So here I have a trapezoid, and I know by definition that a trapezoid has one set of parallel lines. Well, here's how I know that those lines are parallel, because I mark them with a triangle. Okay? If I have a parallelogram, I have two sets of parallel lines by definition. And so here's my first set, but if I mark the second set with triangles, those are not parallel to one another because they're not all four parallel. So what I have to do is I add a second set of triangles, and now this is how I would mark that parallelogram has two sets of parallel lines. Now on the coordinate plane, we're talking about lines and we write equations of lines. This is where the algebra part comes in. So in algebra, or on the coordinate plane, we found out last year that our lines are parallel if they have the same slope. So we have here two equations, y equals 2x plus 3 and negative 2x plus 5 equal negative 5. Now, in order for me to compare the slopes, I have to have them in the same format. And I like them to be in slope-intercept form so that I can tell here that my slope is what is the coefficient of x. So I know here that my slope is 2, and I represent that by the letter m. M equal 2. My slope is equal to 2. I need to put this equation in slope-intercept form in order for me to compare the two. So I'm going to do that by doing a little bit of algebra, and I get y equals 2x minus 5. So now I can tell that both of them have a slope of 2 and they are parallel to one another. Perpendicular lines have a relationship where they meet at right angles. And in order for me to identify them in geometry, I draw little box squares in the right angle corner. Now, if I have a square, I have 4 right angles, so I have to mark all 4 of the right angles. Perpendicular on a coordinate plane, like in with parallel, we had the same slope. Perpendicular, I have the opposite reciprocal slope so that my lines intersect at a 90-degree angle. Okay, so I have that same line, y equals 2x plus 3, and I know still my slope is still 2. But I have to have the opposite reciprocal slope for it to be a perpendicular line. So opposite means positive negative. Since this is a positive slope, it's going to be a negative slope. If this were a negative slope, then the opposite would be a positive slope. So I'm looking for a negative slope here. And reciprocal. Now this is not the technical definition, but I like this definition because kids understand flip-flop. So here I have the slope is 2. Remember, I can write any whole number over 1 and make it a fraction. The flip-flop of that is going to be 1 over 2. So the perpendicular line slope has to be negative 1 over 2. All right, so what if we want to draw a line parallel going through point 2, 2? Well, the first thing I have to do is I have to find the slope. So I'm going to choose 2 points on that line where it intersects on my grid. All right, and I'm going to count my rise and my run. I'm rising up 3 and to the right 3, up 3 to the right 3. So or 2, excuse me. My slope then is 3 over 2. So a parallel line, my slope has to be 3 over 2. I'm going to start at point 2, 2, and I'm going to rise 3 and run 2. And there's my new parallel line. Now what if I wanted to do a perpendicular line going through the same point 2, 2? Well, I have to find the new slope, and the new slope is going to be the opposite reciprocal. The opposite of a positive is a negative, and the reciprocal of 3/2 is 2/3. So my new slope is negative 2/3. So which means that I have one downward movement and a movement to the right, or one upward movement and a movement to the left. One of my two movements has to be negative. Okay, so I'm still starting from 2, 2, and I'm going to go down 2 and to the right 3. New point and draw my line. And that's it. Now, I want to just remind you about horizontal and vertical lines. Remember, horizontal lines have a slope of 0, and so if they're parallel, it's going to be a slope of 0, meaning any horizontal line is parallel to one another. Vertical lines have a slope that's undefined, and so any vertical lines are going to be parallel to one another. And horizontal lines are perpendicular to all vertical lines, and vice versa. All vertical lines are perpendicular to horizontal lines. All right, so let's look at this. What is a polygon? I have here 4 different equations, and I have color-coded mine, and if you are taking notes on this, I would suggest you also color code yours, whether you do it exactly my colors or you do it a different color. That's entirely up to you, but I would color code them. So I was given these 4 lines: y equals 1/2 x plus 2, x equal 2, y equals 1/2 x minus 2, and x equal negative 4. I went ahead and I told you on each one what the slope and the y-intercept were for each one. Remember, mx plus b. So this is my m, this is my b. B is where I begin, and I always begin on the y-axis. Okay, so let's look at the first one. I'm beginning at 2, and I'm rising 1 up and running 2 to the right. All right, so now I have my 2 points. And there's my first line. Now the second line I put here was undefined slope. I know that because x equals a vertical line always. All right, so that means that all I'm going to do is go over 2 and draw a vertical line. This one I'm beginning at negative 2, so down here, and I'm still rising 1 and running 2 to the right. And there we go. And now the last one is a vertical line at -4. So now I have made something in between these lines, and it is a parallelogram. So the polygon that I drew was a parallelogram. I know that it's parallelogram because the slopes of opposite sides are the same. All right. So if I was asked to write an equation for a line parallel to y equals 3/4 x plus 1, passing through the point 4, -2, what I would do first is I would go ahead and know for a parallel line, I know I have to have the same slope. So my slope is 3/4. So there it is. Now I also know this point for -2. I know the x value and I know the y value. I know that that is my new where my new line is going through. Remember when we did it before and we did through point 22? Same thing. So now what I can do is I can plug in the 4 here for y and the -2 here for x. And what I don't know is my new b. So I'm going to be using the y equals mx plus b, and I'm going to be putting in -2 equals 3/4 times 4 plus b. These are going to cancel out, leaving me with 3. And when I subtract 3 from both sides, I get this. And so my new equation is y equals 3/4 x minus 5. Okay? What if it was perpendicular? Okay, so now I need to write an equation for a line perpendicular to that. So I have here, same thing. What is my slope? Well, my slope is -3/1. This time it's not as easy. I have to do the opposite reciprocal, which is the opposite of negative is a positive, and the flip-flop of 3/1 is 1/3. So my new slope is m equal 1/3. I still have an x and a y. I still can use y equals mx plus b. What I don't know is where my new line goes through the y-axis. So I'm going to plug in 2 for y, 3 for x, and 1/3 for my slope, and solve for b. Again, these cancel out. And here is my new line, y equals 1/3 x plus 1. We're almost done. We have 2 postulates that you need to put in your index card notebook. The first postulate is the parallel postulate, and through a point not on a line, there is one and only one line parallel to the given line. There's exactly one line through P parallel to line L. Remember, with all of these, we need to draw it out. So I have here line L, and I have here another line that goes through point P, and they are parallel to one another. Remember, I have to designate that by the triangles. The perpendicular postulate says that if there's a line and a point not on the line, then there's exactly one line through the point perpendicular to the given line. So I have my line, I have a point. Okay? So there is one line going through that point that is perpendicular, and there it is. That's it. Okay, have some fun with parallel and perpendicular. Until next time. Bye-bye.